Well, good afternoon, everyone, or good morning, depending on where you happen to be located. We're glad to have you with us today for our very first Igniter session of NATO's 37th annual conference, putting healthcare data to work. Today's Igniter session is going to be a phenotype library for APCDs by Megan Denham and Jacob Zelko from Georgia Tech Research Institute. You can learn more about them in their bios, which are below the screen. Just scroll down and you will see links to their bios and be able to learn more about them. So at this point, I'm going to turn the time over to Jacob and Megan to explain to us about phenotype libraries and how those could be applicable to APCDs.
All right, thanks, Norm, and hi, everybody. Thanks for coming to our session today. We are excited to kick off the conference. So just to kind of give an overview of phenotyping, as we know, and one of the challenges that we face, particularly with APCDs, is non-standardization of data. And so this is inherent with electronic health records and all sorts of things. So phenotyping is an approach to categorization. You may have heard it in terms in biology and other sciences, that it basically finds groups and categories of similar individuals and puts them into buckets. So this can be really useful to help to standardize medical definitions and make it shareable across systems and states, hopefully eventually.
Could you maybe take a minute and define what is a phenotype a little more carefully and help people understand what that is? And I've got a definition here that you gave me, and I'll put this up on screen.
Yeah. So for those of you who know me, you'll know that I am not the technical person. And so I have to put everything into non-technical terms so that I can understand these things like computable phenotyping. So in thinking of a scenario of walking into a grocery store and you're trying to figure out what kind of water is the most satisfying, or the quenchiest, as we like to refer. If you think about walking into a grocery store and you have two aisles of water bottles, they're essentially, it's all water, but how do you start to put those into categories so that you can analyze similar characteristics? So that's essentially what phenotyping is. So you might put water into buckets of, not literally buckets, I guess you could, but of things like sparkling water, distilled water, spring water, that sort of thing. And so by doing that, it gives you a much more powerful grouping to analyze when you're figuring out what's the quenchiest. Or in medical terms, it's looking at disparate diagnoses. There are lots of different potential diagnoses for something, and being able to put it into one category so that we are able to analyze it much more powerful way. So that's my non-technical way to describe something very technical.
Very good. So why should APCDs care about phenotyping? Why does this matter to the all-pair claims database universe?
Mostly because Norm and Charles say that it's a good idea. No. So basically, the phenotyping libraries represent an opportunity for APCDs to leverage fully standardized data layouts. So we all are familiar with the APCD CDL. And with a phenotype library, we could create a standardized off-the-shelf definition that can be used by analysts, researchers, and medical coders. So even if an APCD doesn't fully utilize the CDL, there are other models like the Observational Medical Outcomes Partnership Common Data Model, OMOP-CDM, that works really well also with phenotyping libraries. So basically, by being able to translate this into different models, then we would be able to share definitions and data across states.
Very good. So how do you go from phenotype definitions, so definition of a person that has a particular phenotype, to something like a cohort? How do we make that happen?
Jacob, do you want to talk about that one?
Yeah, I can jump in a little bit more on this. So thank you, Norm, so much for showing this little flow chart. So this flow chart we put together illustrates a little bit about the idea of how do you go from a phenotype, which is a type of marker, such as in Megan's example, what could be a sparkling or distilled, the different types of characteristics that make the waters different. How do we go from a phenotype all the way to a cohort? So at a high level, you start with defining a phenotype. This can be in practical terms when we talk about patient populations, things such as conditions, measurements, procedures, so on and so forth. Anything that we're interested in looking at as a researcher. So moving on from there, we develop what is known as a phenotype definition. Now, these are definitions that classify individuals with these given characteristics, i.e. phenotypes, and other constraints. One example could be persons with heart disease diagnoses who are also 55 years of age and older. You could add other constraints or other sorts of conditions that you're looking into, but the core idea of classifying with characteristics and constraints remains the same. Then we move on to kind of the most important and step in this process, which is where we actually deploy an idea or a phenotype definition onto an APCD or associated medical database structure. And this is what is known as a computable phenotype definition. This is the procedure that we tell database to follow to find the individuals matching a phenotype definition given our criterias. Seen below in very small text is an example of a query that one could run using the popular language SQL. And then finally, once the computable phenotype has been executed on the database itself, we can end up with CSVs, tables, so on and so forth of these defined patient populations, or in a nutshell, cohorts that we can then analyze going forward.
Fantastic, thank you. So are there already existing standards for phenotype definitions? Do those already exist?
So as of right now, phenotype libraries and phenotype definitions themselves are still somewhat of an emerging field, an emerging area of interest itself in the field of observational health research. However, in a popular or well-known international community known as Odyssey, which is the Observational Health Data Sciences and Informatics Initiative, there is a standardization process currently being created and produced right now on these phenotype definitions that one can, vet, verify, and validate to make sure when we collect or define a patient population and cohort, this is actually accurate to what we're looking for.
Very good. You provided another graphic here. We'll talk about that in a minute. Let me just put this off the screen for just a second. So when it comes to APCD phenotype library, first I'll talk about the process. How far are you in the process of developing a phenotype library for your APCD? And then talk about how we could make that more available to others.
Yeah. So I can comment a little bit on that. So on this region right now, we're still in the process right now of getting our APCD set up as the analytics core. However, a case study that we're currently doing is focused around chronic mental illness, which uses Medicaid patient claims information to assess prevalence rates and other sorts of metrics around subpopulations throughout the state of Georgia to determine with these chronic mental illnesses such as suicidality, depression, or bipolar disorder, prevalence rates amongst subpopulations broken out by things such as race, gender, etc. And while doing this, we've developed phenotype definitions ourselves to show, okay, these are phenotype definitions that can be used in this example study of just raw patient claims information that's been adapted to the OMOP common data model, which is what Megan referred to earlier. But in that same process, as we've been building capacity to develop these phenotypes ourselves on this pilot characterization study that we're running assessing chronic mental illness, we do hope to bring and adapt it to our APCD phenotype library ourselves as we develop our analytics core at the Georgia APCD.
Very good. Megan, do you have anything you'd like to add in terms of the value of phenotype libraries for APCDs and how you plan on using this for your APCD?
Yeah. So one of the things that we're kind of exploring now are what are all the potential applications of phenotyping libraries. So one of the things that I am that's really important, I think, to me and to the world right now is privacy and so forth, and figuring out how to. I think one of the potential applications are for categorizing sensitive data, more sensitive data. So substance abuse, mental disabilities, that sort of thing. But as there are emerging categories of sensitive data that need to be protected, and that can be challenging, that this is one potential way to flag those cases and separate them off so that we can still have access to those data, but ensure that they are protected. So that's one potential application that I hope we'll be able to use it for.
Great.
Yeah.
So,
I could jump in, Norm.
Yes, jump in.
Yeah, just to kind of tag. Yeah, sorry to tag in real quick on this point. So another area that APCD phenotype libraries could be really useful for is, say, if we do eventually build up our own APCD phenotype library that exists across the APCD community. This could be a really useful mechanism for other APCDs, be it as they stand their own APCDs up, as they adhere to the NATO common data model or common data layout. They could use these phenotype definitions as almost off-the-shelf solutions on their APCs themselves, and we could actually, through the APC network, potentially do more straightforward, perhaps even apples-to-apples comparisons of, if, say, state A is saying we're going to use this phenotype definition, state B is going to say we're using ones, you could potentially compare the same metrics, possibly. It's just an idea for future research down the road, or how this could be used.
Okay, so just to maybe kind of clarify then, to make sure everyone understands. So if you have more than one APCD and they're using a common phenotype library, then that opens up the door to doing multi-state or cross-state analysis on these different types of diseases or procedure dates, or it could be any of 100 different things, right? Or maybe even 1,000 different things.
Yeah, and I see Megan smiling too, so I'll let you comment in just a second, Megan. But absolutely, Norm, as you're saying, like the opportunity for this is very rich, and it would help facilitate and hopefully make that interstate, collaboration efforts more feasible, as well as more possible amongst the APC network. So, Megan, I'll let you comment if you want to add anything.
Yeah, I think that one of the values that this stands to serve to APCDs in sharing data, because I think that's what we're all hoping for, right? The more data, the more excited we get. But one of the challenges that this can help to address are the kind of the fairness in reporting as patients are coming into hospitals. There are biases that are inherent in the way that they're diagnosed based on gender, based on race, based on these different characteristics. So, for example, men will usually appear they'll present as chest pain when they're having a cardiovascular event, whereas women may have pain in other places. And so to really understand the true numbers of the cardiovascular disease prevalence, then we need to be able to equalize that across all of these innate biases. And those are going to be variable across states. So this allows us not only within our APCDs, but across our APCDs to be able to correct for these non-standardized presentations.
So does the development of the phenotype library, the way you envision it, does it rely on everyone collecting the underlying data in exactly the same way? Or is there some ability to kind of have a little bit of tolerance, if you will, for different ways of coding the data?
Yeah, so to kind of comment on that, so say with, be it the common data layout, if an APC still chooses to adhere to that, or, if someone, takes the APC and makes it interoperable also with the common data model, for example, both of those standards do have a lot of flexibility. So in my own research with the case study on chronic mental illness, partner sites that I've been working to conduct this study on characterization around depression and these other conditions do have extended fields or extended use cases of their standards at their particular site. But, as I don't have a use for that data, for me, I don't need to necessarily worry about that they have an extended standard or not. I just can work with the data that I know that they definitely have per standard and just use that for my study. So that you do have that flexibility to add more for a given state or a given site.
Okay, good. We do have a question here. I think now's a good time to tell Williams at Stern. What is the difference between phenotype and taxonomy? If any, there may not be any. I don't know. This is not my field.
Jacob, I'll let you take that one.
Yeah, so I would say I will be honest very much so that I'm not so much a biologist as I do know what you're referring to with taxonomy, is that I'd say it's a good question. I'd say that loosely with phenotypes and taxonomies, I would say that personally, as I just understand taxonomies right now, that they are very similar. But I would say like when we're using the word phenotype right now, we're more referring to the human species rather than a broad range of species. But then, as you're saying, like a taxonomy itself can have multiple different characteristics, same as a phenotype. So I wouldn't necessarily use them interchangeably, but I'd say they're very, very similar.
Okay. So for example, could taxonomy be more applicable to social determinants of health, whereas phenotypes are characteristics of the human being? Is that maybe something that you're getting at?
That's a really good point. And I would say if we want to expand, a definition of a phenotype beyond just, the person, as you said, kind of Norm, to something that's more outside of the person, such as a social determinant of health metric or what have you, then yes, I would say in that case, things such as like the social vulnerability index, which comes from the CDC, or other such metrics, I think would fit well under the umbrella of what would be known as a taxonomy. So there's this flexibility, I think, to expand our vocabularies, especially when we're at APCDs.
Okay, now we have a similar question or related question from Ashwini Sankar. It sounds like phenotype can change over time for a particular person. I think I know the answer, but I'm interested to hear how you would all address that question.
So I would say, well, I'm not the technical person, but I would say yes, they certainly do. And as it'll also change with medicine advances, as we change our coding practices and diagnostic practices and all of that. All of those things are likely to change over time. So it's not necessarily locking somebody into a specific category or group. It's just allowing us to analyze the snapshot of the data as it is there. Jacob, what would you add to that?
I think that idea of a snapshot is a very good point because, as you do your analyses, speaking a bit more to the technical side, as you do your analyses, we will be operating more on a point in time when we do that analysis. But, this also makes the case for why it's so important to have, claims reported to APCDs such that we can continue to follow, say if a person's diagnoses or conditions are changing over time, we can see that reflected in the APCD and also follow that over a continuum of a person's, medical life.
Okay, well, we've got just a couple of minutes left, so let's go ahead and put this on the screen and wrap up with this. So what are some of the ongoing limits with phenotype definitions? And then we're going to leave this as a resource for people who want to learn more about this. But let's answer that last question. Megan, what do you think?
So one of those limitations is as we're referencing the fairness in reporting and the bias of diagnostics based on the individual's presentation or gender or race, ethnicity. So that's part of the challenge, is identifying what those biases are and sorting them out so that we can really identify what those phenotype categories are. There's also a challenge with the disconnect between diagnostics and claims. So claims data are not necessarily exactly specifically in line with diagnostics. So, for example, if somebody presents with a traumatic brain injury and a cognitive disorder, NOS, it might, for claims purposes, be listed as cognitive disorder as a primary diagnosis and traumatic brain injury as a secondary diagnosis, because that's the way the claims work and as far as reimbursing a particular condition. But for diagnostic purposes, which one is first and second isn't so important. It's more about identifying what the biggest issue is. And so teasing that out and figuring out where it doesn't matter what's first or second and the comorbidities and everything, whether they're relevant or not, that can be challenging as well. And okay. Jacob, what would you add to that? Oh, we're almost
just to finish on that thought, zooming out from that more, specific example, also from a general level. So let's say, theoretically, we do have an APCD phenotype library that gets deployed. as Megan mentioned earlier, there's this example of how, women might present, not women, men might present with chest pain when there's a myocardial infarction or another heart event that someone's presenting with. However, a woman, based on medical literature, might present with different sorts of pain. But if the primary phenotype definition that we're using as in a phenotype library for an APCD, or heart attack or chest pain, or just pain in general, is focusing on just looking at chest pain, then we might severely underrepresent women in any phenotype definition that we use. And if we produce that as an artifact for the APCD community and people start using that off the shelf, that could have severe consequences across the APCD continuum, which is why we would need that standardization, that vetting process to make sure we're not accidentally underrepresenting or overrepresenting certain populations for phenotype groups.
All right, well, thank you. We are at time. It's been a very fascinating discussion with you today. We've got some resources on screen for those who are interested, and this recording, this session will be recorded. The recording will be available in the same spot within about a day. So if anybody wants to share it with their friends and say, hey, come back and see this, it'll be here in about a day. So thank you again, Megan and Jacob, and thank you for those that participated online with us. It's good to have you today. We will see you in 1 week from today. We will be back here for a discussion of data transparency. What's new in the world of hospital data transparency? Thank you, everyone.
Awesome. Thank you.